First, we use sampling technique like simple random sampling (SRS). This is because this technique choosing the number randomly from a population in the table. And second, quantitative data can use in this report because quantitative data represent numerical values or quantities that can be measured and analyzed statistically. In addition, they can be discrete or continuous. And third, level of measurement in this report is ratio level. This is because the ratio level of measurement is the most sophisticated, incorporating all the properties of nominal, ordinal, and interval levels, with the addition of a true 0 point. At the same time, data has consistent intervals between value, a 0 point, and allow for meaningful ratios between value. Table. For the table, we have a frequency distribution, relative frequency, cumulative frequency. Okay, this part I want to show how to find the answer of the table. Firstly, frequency distribution. In this part, we can find the class of K. So, we should choose square the similar with our total and 50 sample in the table, like square 6 equal to 64. And next, relative frequency. For the relative frequency, we just calculate the frequency debate with sample size n. Last but not least is about cumulative frequency. The cumulative frequency is the class at the same of frequency for the class at all previous class. The cumulative frequency of the last class is equal to the n, sample n. Graph. In this part, we choose the two graph like frequency polygon and histogram. Okay. In the frequency polygon, we have the class interval, midpoint, and frequency. So, I will explain how to find the midpoint like lower class limit plus with the upper class limit and divide 2. While the histogram, we use the class interval, lower boundaries, upper boundaries, midpoint, and frequency to create the graph.
Today, I want to present about measure rate of tendency, measure rate of variation, and distribution. So, for me, is fx divided by n. So, the answer is x 3252 divided by 50. The answer is 65.04. So, for median is ln plus n divided by 2 fm minus 1 divided by fm multiplies c. So, the answer is 53.5 plus 25 minus 14 divided by 13 and multiply 18. So, the answer is 68.731. For modes is ln plus tangent 1 divided by tangent 1 plus tangent 2 multiply c. So, the answer is 43.5 plus 9 divided by 9 plus 3 multiply 80. So, the answer is 67. For measure of variance has two simple. First is variance, second is standard deviation. First, for variance is 1 divided by 50 minus 1 multiply 279876.5 minus 3252 power of 2 divided by 50. So, the answer is 1395.233. So, the answer is 37.353. Shape of distribution means 65.04. So, for the answer means smaller than medians, medians bigger than mode. Therefore, is quicker to the left.
Okay, so I am going to present part B, question 1 and question 2. The data we use is from kaggle.com, which is the data sets about cardiovascular disease, systolic blood pressure according to the patient's ID. The sample size of this data is 50. The independent variable, which is X, is weight, while dependent variable, which is Y, is systolic blood pressure. Next, for question 2, the sample size, type of data, and level of measurement used. Okay, for the first one, which is the sample size is 50 people from all patients that have cardiovascular disease. Next, the type of data is quantitative variable, which can be measured numerically or counted. And the last one is level of measurement used. Level of measurement used in this report is ratio scale.
Hi, my name is Nur Anabla binti Mat Nasir with metric number H22A1024. Based on the data set here consists of n greater than 100, then I may select at random. Nevertheless, n is not greater than 100, but n must be at least 30. For example, n equal 50. So, after all, this is a data that we study collected, which is n equal 35 sample patient ID.
Next, I will discuss about the Pearson product moment correlation coefficient. So we use the following formula to find the Pearson correlation coefficient. We have 50 data and this data is used to calculate correlation coefficient. Then we insert all 50 data into the formula and the answer we get is 0.24. So the Pearson product moment correlation coefficient suggests a weak positive linear relationship between weight and systolic blood pressure.
So here is the estimate regression equation that we have interpret using Excel apps. The calculation starts with the numerator of this formula is the covariance of x and y divided by the variance of x. The denominator is the variance of x. Next, plug in specific values of x, y, and n. This results in the following picture. So, the slope of the least square line for this data set is 1.90. The next step is to find the y-intercept of the line. Y-intercept of the least squares line for this data set is negative 17.77. Finally, the equation are y equal negative 17.77 plus 1.90x. This is the equation of the line that minimizes the sum of the square distance between data points and the line.